Hello, hi everyone. Welcome to the Africa STEM Summit. This is a 3-day summit curated to inspire, mentor, guide, and expose individuals to the technical skills they will need at every level of their career journey, from the junior to intermediate to senior level. The goal is to bridge the skills and gender gap in STEM, and you can be able to follow the speaker's link using the LinkedIn link that has been added to the description box of this video. And you can be able to carry on with the conversation in the chat section as well as in our socials at Africa STEM Summit, and also using the hashtag Africa STEM Summit hashtag. Today, we are going to be hearing from Lenny Ng'ang'a, who is a backend developer, and mostly I think he is currently doing a lot of research on robotics. I hope you guys ask him a little bit more questions also on that area, even though today he'll be talking about backend. But robotics is here to stay, and I think that is something that we will hopefully get him next time to explore or to tell us more about what that looks like, especially in the Kenyan landscape. So welcome, Lenny, to the Africa STEM Summit.
Thank you. Thank you, Stella. I am very happy to be here today and to be sharing knowledge in terms of what I have learned over the years. And for sure, we'll talk a little bit about robotics as we get started before we get a deep dive on building APIs with FastAPI, which is what my talk today will be based on. I will get to see a lot of my background in terms of what I'm working on and some of my hobbies. And yeah, that should get people excited in terms of what is available in STEM. It's a broad field, and I hope we do get a lot more people in STEM. So, without further ado, I think I would want to jump right on and start the presentation if that's okay. So, a moment while I share my screen. I hope that my screen is visible. I cannot confirm from my end, but I don't know if I can get someone to comment or to let me know that my screen is visible. All right, yeah, I think I've gotten a confirmation that we can proceed on with the presentation. So let me just get this started. Right on, right on. So my name is Lenny Ng'ang'a. I am currently a backend engineer at a startup called Instagrosa, a full-time software engineer at Instagrosa. And for my part-time, I do work as a robotics researcher at a robotics lab called Robotics Dojo. So how I got started and how I found myself in this particular roles. One of the key moments in my areas, I think, is about 3 years ago. Three years ago or so now, we co-founded a startup with two of my friends, and it was basically a smart farming startup where we built technology that will enable farmers to to manage their farms remotely. This will entail managing the irrigation schedules, monitoring their farm conditions such as soil temperature, humidity, and this will generally inform the overall farm health. So, unfortunately, this startup we ended up shutting it down due to various challenges. But at the time, I was working as the software developer inside the team. We had a guy working on the hardware development, and then we had a business developer who would get us in touch with the actual farmer. So most of the work that I'm proud of actually happened in this startup where we were able to build technology that actually got into users' hands, and was not just technology that we built for our own GitHub profiles, as most of us do. Moving on, as I mentioned, I currently work as a robotics researcher. My journey into robotics started in robotics competitions. And this usually would entail being able to build a robot that can do a particular set of tasks, whether it is following a line or being able to collect objects along the way and placing them in a particular goal. Usually, at the end of the day, a robot must be able to avoid obstacles on its way to from point A to point B, and that has been something that is very common in robotics competitions. Anyway, apart from doing the competitions, uh, my work in robotics got supercharged when I got asked to be a trainer and a curriculum developer at Robotics Dojo. So Robotics Dojo is a robotics research organization currently developed at JQuat, and they have access to a lot of robotics resources and facilities. And based on my work on previous robotics work, I was invited to work on a new robot that had been built and commissioned at JQuat, that is Jomo Kenyatta University of Agriculture and Technology. And my work basically entailed building libraries for the robot. And the libraries are what are currently being used by students in order to build upon the research projects. My focus in robotics right now entails using computer vision. So this involves using cameras to enable robots to see, much in the same way that we human beings move around the world using our eyes. So that is currently what my robotics research work focuses on. And alongside that, there's a lot of deep learning, machine learning, basically, and all the AI stuff that we've been hearing being thrown around in the past few months. Really, it has been an AI frenzy. So robotics is one of the fields that gets to employ a lot of AI, and I'm happy to be working in this particular field because it's at it's at the center of so many other technologies that it makes it very, very interesting to work in robotics. But anyway, this is subject for, it's a talk that we'll have another day. So I'll go back to the focus of today and proceed right on to the next slide.
Hello, Lenny, can you hear me? Hello? Lenny, can you hear me? Lenny? Oh my God. Hello, hi Lenny, can you hear me? Hello, hi Lenny, can you hear me? Lenny? Can you hear me, Lenny? Hello? Jesus. Hello, hi Lenny. Hello, Lenny, can you hear me?
Just a moment.
Yes, now I can hear you. Your voice, we lost you. Okay, so let us give Lenny a few seconds to sort out his sound, and then he will just do a short recap of what we have missed. Yes, so maybe you can let us know where you're joining us from, and what level of, if you've ever interacted with FastAPI before, and are you a front end or a backend developer? So you can let us know as we give Lenny a chance to sort out the issue. So you can chat with us in the chat section. Thank you.
Hello everyone, am I audible? I've just been notified that there was issue with the sound.
Yes, now you're audible. Thank you.
Oh, perfect. I think I figured out what the matter was. Let me just go back and we can talk about where I dropped off. Is this a place where I dropped off? I don't know where really I should start from. So Stella, if you might be able to tell me where to start from.
Just go back. We lost you when Flash. No, where it had Flash. No, it's here. I think
Oh, all right.
we talked about the funding. Yes, here.
Ah, perfect.
Okay.
All right. Yeah. So I have been notified that I was talking to myself and I had not pulled up the actual comments to see what was going on. But thank you, Stella, for notifying me and reaching out. So as I'll just go through this slide again. It's an important one in order to establish why we need fast API in the modern world and why it has come to be revolutionary. And the first thing is that it's built for speed right from the ground up, based on its architecture, how it was basically laid out from the beginning using a framework like Starlet. It's built to the core to be able to utilize as much system resources at its disposal as possible. And this has made it on at par with Node.js and Go. So when it comes to API development, Node.js has been particularly popular, and this is because it has been there for a while and has many features that has made it very popular among backend developers. But Go was then invented by Google, and it came over, and we all loved it. And for the longest time possible, we were trying to build APIs with Python, but we did not have a tool built specifically for APIs in Python. So Django is a popular web framework. Django does allow you to build APIs. Flask does allow you to build APIs using the RESTful extension. And you can see that these are web frameworks primarily built to build web applications, but we found workarounds around building APIs. And so for some of these reasons, we're not able to build very robust APIs, but Fast API was built with APIs at the core, and that is why it's the focus of the API development world, especially as far as Python is concerned. So the other thing about Fast API is the rapid development. So being able to iterate quickly through whatever problem you're trying to solve is very key in development. As soon as you can be able to get an issue done and move on to the next, well, the better it is for you. You just get focused on how fast you can basically build up your product, and not only building up the product, but also when in production, whenever you have issues or you have to add on to features, how fast you can then fix those issues or how fast you can iterate through feature development is also very key in backend development. And this is especially because when you are working as a software developer and your APIs are out there in the world, they are usually tied to actual finances. So actual money that goes into not only running the API, but actual money that then the users are able to generate in terms of revenue for the company. So when you're building APIs at a company level, usually it is service critical and you do not want any downtime. And if you can iterate through being able to fix problems as soon as you get them and being able to churn out new features as soon as you get as soon as you get feature requests or as soon as you get feedback from your customers, then that is usually a very good upper hand that you have, and it's leverage. So that is the other thing about Fast API that enables you to do. The other thing is that it minimizes human error, and this particularly is related to types. So in the software development world, there's usually statically typed languages versus dynamically typed languages, and there is that debate of whether dynamic languages are better than static languages or static are better than dynamic. But one of the upper hands that statically typed languages like C, C++, Java, etc. have is that they are able to restrict the types of data that you put in a variable. So if you declare a variable to be an integer, for example, you cannot put a string inside that integer. And such kind of type checking enables you to minimize errors as far as data validation is concerned. So this is where a dynamic language will miss out on. But from Python, I believe 3.7 or 3.8, type hints were introduced. So Python does have the ability to be able to define variables and to declare variables as being of a particular type, which is something that most people are actually not very familiar with, but FastAPI leverages this in order to ensure that you have that data validation there. And the particular tool that is used, as we will see in the preceding slides, is that Pydantic, which is a tool that FastAPI uses these type hints to ensure that whatever data is being passed on from the client is the type of input that we are expecting in our API. So that is the other benefit of FastAPI. It is short and easy, again, in line with Python's philosophy, whereby we do not have any boilerplate code. You want to print hello world, you just print hello world. I am taking a shot at all the other Java, C, and C++ developers that we have in the audience. I am also a C++ developer, so it is fair that I am saying this against other devs because they also get to take the pinch. And well, side note, I use a lot of C++, not for web development, but for robotics work. So whenever you are programming these actuators and this uh, microcontroller system, C++ is usually the language that we go for. But well, that is on a side note. It will be very, very painful to build an API using using C++ or try building a web framework using C++. That will just be totally, maybe do that as a side project, but not really as something to do on a day-to-day basis because it will be pure torture. The other thing about FastAPI is that it's production ready. So when using Flask, for example, you have to do a lot of manual tying things up together in order to get your API to be ready for production. But FastAPI was built at the core with production in mind. And just a list of a few companies that use FastAPI. There are many, many companies. I could not even finish going through that list. And I do have resources in terms of um, the content that I'm getting for this presentation, as well as the data that backs up what I am presenting today. So at the end of the slides, you're going to have all the resources that I'm going to be pointing to so that you can go and verify for yourself that indeed FastAPI is here to stay and is being used by so many companies. It is important to check on the types of companies that are using FastAPI, and this is in line with other products as well. Whenever a big company, in this case a FAANG company, Facebook, now Meta, Apple, Amazon, Netflix, Google, whatever, whenever we have such big companies using these kinds of products, it usually speaks to a product sustainability and its reliability. So given that Netflix, for example, uses FastAPI, you can be certain that, well, FastAPI is not only here to stay, but it's been built with a large scale number of users in mind, given that it can support the crazy workload that it's exposed to at these big companies. So moving on. All right on to the gist of the talk. So we are going to actually set up a fast API project, and we're going to be doing most of these things live, really. So feel free to also add a few suggestions in the comments so that we can be able to build something that is robust and something that has been built as well by the audience. So I'm going to get started on how to set up a fast API project. We are going to open up a code editor. In this case, I'm going to be using VS Code, and I'm going to be setting up FastAPI, setting up the project structure, and getting on to building a very quick demonstration of what FastAPI can do. We are going to basically build an API in less than 10 minutes, and that speaks to how fast you can set up projects, and especially in this case, applications using FastAPI. So I'm going to switch my tab now to VS Code. And maybe increase the font size so that we are all able to see what's going on. And it doesn't really matter what type of code editor you use. Actually, the other thing that FastAPI developers took to heart was they were able to build support for almost all code editors out there. So whether you use PyCharm or VS Code or Sublime Text, you're going to get inherent support for FastAPI in terms of code completion and features such as that make development easy. So first things up is that I'm going to set up my local environment. Usually, well, this is not the subject of the talk, but whenever you're building Python projects or you have so many Python projects, as when you are beginning as a junior developer, let's say, building environments is usually not very critical and usually not very important as a step to doing projects. But once you start having more than one project, you get to see why you would need to set up virtual environments. And nowadays, there are tools such as Docker that take environments to a different level, and it's what we actually use when deploying applications nowadays. It's the standard sort of in industry to deploy APIs and other types of applications in form of Docker containers. And we'll talk a bit about that at the end of the talk, where we'll get to see or we'll get to discuss the deployment strategies around FastAPI. But for now, I'm just going to again increase the font size and set up my virtual environment. I'm using Ubuntu Linux. So some of the commands that I type are not going to be the same in Windows. You'd have to check the Windows alternative if you're using Windows. But if you're on a Mac or a Linux-based system, then these commands will work right off the box. So in this case, I'm going to set up an environment. And it's called VNV. It comes inbuilt with Python. So as soon as you install Python, you already have access to VNV. And there are other virtual environment tools that you can have in Python and you can install as third-party libraries. But well, I get to use what Python comes with, and that is accessible to everyone. So that is what I'm going to be working with. As soon as you have your environment created, what you need to do is to activate the environment. So being able to use that environment so that you can then install packages. In this case, we're going to be installing API inside our virtual environment. This is one of the commands that is different in Windows. In Windows, this will be VMV scripts activate, but in Linux systems, it's bin. So again, just speaking to the various differences that we have between the two types of systems. So we've activated the virtual environment, and from the terminal, you're going to see that we now have this Venv sort of superscript before all our commands, and this shows you that you've activated your virtual environment. To deactivate it, I'll just type deactivate, and that should be able to deactivate the environment. So I'm going to go back to my activated environment, clear the terminal, and then I'm going to install FastAPI. So FastAPI is a relatively small tool. We should be able to get it going even live. I do not need to have pre-installed it. This is contrary to other big libraries that you have in Python. If you are working, for example, in machine learning, most of those libraries are actually very big, and you actually, whenever you're installing them, you'd have to go get a cup of coffee, then come back and finish up the installation because they are very, very large packages. But FastAPI is rather slim. And I have installed the full version of FastAPI. FastAPI does have a minimal version, so basically entailing the build systems around FastAPI, and that goes for people that would want to install a very clean FastAPI install. And I guess the parallel that I can draw to this is Flask versus Django. So Django as a web framework usually has a lot of tools. Whenever you need to, let's say, build a form for your web application, Django does have a form tool built in. Whenever you need to do password validation, Django does have support for that natively. So that Django is usually referred to as a batteries included framework, but Flask on the other end is usually a very minimal framework. Whatever you need, you're going to have to install. So FastAPI does have a minimal version of it called FastAPI Minimal. So that is something that you might want to go look at the FastAPI documentation. But with that, I even did not notice that the installation was complete. We're going to move on to setting up a FastAPI application. So I'll open my VS Code window. I'm going to set this to open the current folder in which you are working on, and it's download/FastAPI. So allow me to open that so that you can be able to navigate through. You can be able to navigate through the files that have been created. And as you can see, we do have that VNV virtual environment that was created by Python when we started this. I'm going to create a new file and call it main. And you're going to need a few things when creating a FastAPI app. So I'm going to get onto that. And then I'm going to define my application. I'm having a bit of lag on my end. Let me see if I can make things go a bit zippier. All right. We define our app as a FastAPI instance. And then the next thing that we get to build is what we call a route or an endpoint. And we're going to talk more about this once I pull up the slides again. But let me just type it out, and then we'll get to discuss what this does. And for those that are not aware, you can actually have emojis in code. So let me see if I can pull that. You can be able to type out emojis. Emojis are just characters at the end of the day. So if I put a raised hand, I'm using a VS Code extension that gives me access to emojis. But an emoji is simply a character. It's just as it's very similar to typing out a number or a letter. So yeah, do not be surprised to see code bases out there that do have emojis, and I do like putting emojis from time to time to keep things fun. So we have that, and that is the end of our FastAPI application. I'm going to pull up the terminal again so that we can be able to run this FastAPI application. So my virtual environment has currently been disabled. I'll have to enable that again. And then all you need to do is to type FastAPI. Dev meaning we are currently in development, and whenever you are developing your FastAPI application, you're going to be using this command, dev and then the name of your file. When you are in a production setting, you use FastAPI run. The difference between dev and run is that firstly, the dev environment gives you access to a lot more logging. So you can be able to see what is happening behind the API as it's executing the request that it's getting from the clients. And you're also going to see those errors again in your front-end client. So let me expand this so that you can see what is happening. FastAPI has already run. And one of the benefits that you get when you are in development mode, again, you can see the message from FastAPI telling you in production, you can use FastAPI run. The benefit of development mode is that you get access to a lot of what is happening inside the FastAPI application. And besides that, you're going to get a lot of very beautiful error messages that are going to make your development time very, very easy. So our application is already running. I'm just going to go back to our browser. I wonder if I can switch tabs immediately or I'll have to move out of the presentation view. So from our logs, we can see that it is running on 127.0.0.1 and then full colon 8000. To those that are unfamiliar, we're going to look at the structure of a URL anyway, but I'm just going to visit that link that FastAPI has told me it has built on. And I am also one of the few developers that use Edge. Most people use Chrome. Anyway, here you go. So we have gone to that URL and we can see that we have gotten the message Africa STEM Summit. One of the things that you get with FastAPI is that it comes with inbuilt documentation. One of the boring things to do is to write documentation for your API endpoints. And usually what FastAPI has implemented is that if you visit that base URL, that's 127.0.1.8000, and you navigate to /docs, you're going to find some very beautiful documentation around what you have built. And this is enabled because FastAPI is built on standards called the OpenAPI standards. And whenever you create a FastAPI application, FastAPI goes ahead to look at what you've coded up, builds an OpenAPI standard spec sheet, and that is what it passes on to this Swagger UI so that you can be able to see, to get this visual representation of your application. And this serves as a very simple front end that we can use for demo purposes. So I'm going to press try it out. And what happens when I press execute is that we are going to see what the API returns. So you can think of this as, let's say, your front end client. Someone has just pressed sign in or sign up in your application. So what happens? What data is then brought back by your API after processing? And you can see down here that we have the message Africa STEM Summit 2024. So this is what is returned by our API. So before we get into the weeds of APIs, we're going to look at we're going to talk about a few basics behind APIs. Basically what I'm talking about when I talk about endpoints, when I'm talking about routes, some of these things are not familiar to most people, but we are going to get onto that right now. And I think this is a better way of presenting this. Presentation. I find it to be faster this way, so I hope you don't mind that it's not full screen. So this is what we've just done. We have installed FastAPI and we have built a basic route. Now what I want to focus the next few minutes on is defining routes on FastAPI. And there are 4 types of HTTP methods that are very common. So if I go back to my code and remove the terminal, you can see here we used app.get. And for those that are unfamiliar with Python syntax as well, this is in Python called a decorator. Whenever you have an @ sign, whenever you have an @ symbol on top of a function, that is called a decorator. You can think of it like a hat. Whenever you as a human being wear a cape, that cape is a decorator. It's decorating you. So in this case, the @ symbol invokes a decorator for this particular function. And what it basically tells FastAPI is that whenever someone visits this base URL, we want to display this message, and this message is displayed by invoking this function. So FastAPI then attaches this particular endpoint to this particular function, and we can demonstrate that this works by defining something else. Let's say this will be /main. And whenever my VS Code is set to autosave after every 3 or so seconds, so it has already autosaved. And because we're in development mode, you don't need to go and rerun the FastAPI dev main.py. Whenever you make changes in any file, FastAPI is going to automatically notice those changes and reload. So it has automatically reloaded. And that means if I go to my browser again, this time around, if I refresh, I should now see we have a new route called /main. So that is the actual endpoint. So if I get rid of the docs just to demonstrate, is that if I now visit /main, we should be able to get the same message, um, Africa Tech Summit, Africa STEM Summit. Yeah. All right. Again, we're just going to try it out. Press execute, and there you go with the message. So the explanation here is that this is a decorator, and this tells FastAPI that the function defined below should be attached to this path. Whenever someone visits this path, then execute the function below. Now, in this within this decorator, we have multiple methods that we can use. This one is /.get, and we can have get, post, put, delete, patch options, and many other types of HTTP methods. So, for example, here we get using a get method, and this is used whenever you just need to read data. So, for example, you want to get a list of users in your application, and we're going to set something up similar to that. Whenever you want to, let's say, add a new user, someone has just signed up on your platform, you want to add their name, email address, and what have you. So that is what you use a post request. A put request is used whenever you want to update the data. So once I have already signed up onto a platform, but I want to edit my first name, for example, and I want to use that via the API. I'm not going to use it as a post or a put, as a post or a get request. I'm going to use a put request. We're also going to demonstrate this as we build up onto whatever application we're going to be building. The other thing is that the delete request is used whenever the delete method is used whenever we have an endpoint that is used to delete a user or to delete any data in our database. And usually you'll hear about the CRUD method whenever you are reading or looking at APIs. This is something very common to see. And CRUD stands for create, read, update, and delete. And the corresponding methods are post, get, put, and delete. We do have other HTTP methods. These are not very common, and they're usually very exotic, tied to very specific applications. And it's very common to find an entire API, a production level API that just utilizes these four HTTP methods and does not get into the weeds about what these other methods entail. So I'll also not do that. I'll just stick to these four methods. And I'm going to pull up a quick demo again. So we're going to stick with that construct of users. So I'm just going to create a simple Python list. And I'm going to add Stella to this list of users. I'm going to add myself. And I think I could pick someone from the comments. I'm going to add Edwin. And I currently have a GitHub Copilot active. I'm actually going to disable it so that we then have that experience of live coding. Sometimes it's helpful, but whenever I want to learn something or I'm trying something new that I haven't tried before, I usually disable GitHub Copilot so that I can then struggle with the problem a bit. That's how best I learn, but other people have different preferences. But I have turned it off for our case here. I do not want it to be auto-completing things that I want us to go through. So we now have our list of users, and we want anytime we push a get request to an endpoint called /users, we want to return this list. So I'm also going to name this function. I'm going to rename it from main to maybe get all users, and I'm also going to tidy things up a bit. and it's going to be as simple as that. So right now, I expect that FastAPI has already reloaded. We can come back to our application, refresh the page. There are changes that you do in the backend that do not require you to refresh the page, but just always refresh to get rid of some frustrations down the road when you've made a change and you do not understand why you're not seeing what you're supposed to see. But yeah, as you can see, I now get my list of users back in my client, and that is happening because I'm executing a get request to the /users endpoint. I'm going to add a few more endpoints, and before maybe I get too much into the weeds of endpoints, let's just quickly define them and then get back to development. So in FastAPI, but generally in the API world, you're going to find endpoints being interchangeably used as or defined as paths or routes. So whenever I refer to a path, I'm just basically talking of an endpoint. Whenever I talk of an endpoint, I'm also referring to it as a route. So I might use these terms interchangeably, and it's actually what happens out there. So this is one of those pages that the image might not be very visible if it's not full screen, but I do hope you can be able to see what I have here. So I wanted to maybe not focus too much on the various sections of this URL. So this is the URL. Whenever you visit any site, every site has a URL. But the 127.0.0.1 is our host, our domain name, and then the port was 8,000. And then everything that follows after the slash, so whether it is /users or /video or whatever, anything that follows after the slash is what we refer to as an endpoint. So here it does not matter the various subcategories of an endpoint, but the important thing to know is that anything that follows after the slash is an endpoint. So this /users is actually an endpoint. And as I said, I'm going to be referring to this as an endpoint or a path or a route. But whenever it's important to make the distinction, I am going to do that. So I'm going to create a few more endpoints now that we know what endpoints are, so that we can then get on to see how to use the various HTTP methods. So we did use the get to display our users. I'm just going to copy and paste this because it's going to be much faster that way. And this is going to be a post request, and add new user. And at this point, I'm not going to showcase how to add a new user just yet. There is a missing bit, but we will get to build onto that slowly. So I'm not really worried about that. I'm going to copy that again. So that was a get request, a post request, a put request, and then we are going to, again, name our functions accordingly. So this is going to be update a user. And finally, we want delete. So right now, all these endpoints basically do the same thing. And it's one of the things that I'm going to talk about as not necessarily a feature of FastAPI, but one of the ways FastAPI is structured is that it does not enforce this. So I do now have my 4 endpoints, all of them targeting users. So my user endpoint has 4 methods attached to it. So, and anything that I do to any of these will return the same thing because we've not added any particular logic. So in this case, whenever I execute a get request to the user's endpoint, I'm going to get my list of users. If I go right on to, let me minimize that. If I go to delete user, I just write out. I'm not actually deleting anything because we've not put that logic just yet. But as you can see, we are able to apply all these different HTTP methods. So the thing that I was talking about is that FastAPI does not enforce these methods. And what that means is that it does not force you to use the delete endpoint or the delete HTTP method to actually delete a user. I can, for example, do everything through a GET request. I can add a new user from a GET request. I can update the user from a GET request. I can get all users from a GET request, and I can as well delete a user using a GET HTTP method. So FastAPI does not force you to use GET for reading data, put for updating data, post for creating data, and delete for deleting data. That is something that is more or less an API convention. So it is best practice to use those particular methods as they were defined. But if you find yourself mixing them up, well, FastAPI is not going to be shouting at you in terms of not using the defined, not using the defined HTTP methods correctly. Yeah, so that was an important thing that I think I needed to mention before we go on. So I'm going to go back to my code, and we're going to build actual logic towards this so that I can now start talking about specific features about FastAPI. So let's go to the next slide. And we are going to be discussing this once we've built the actual logic. So I'll come here. And I wonder whether I had already defined the types of endpoints. Yeah, I think this is the missing slide. I did not talk about what I meant by path parameters, query parameters, and the request body. So these are the various ways we get to interact with an endpoint, basically passing data to the backend. And starting with the very simplest one, this is the path parameter. I'm going to demonstrate how to use that. And I think the basic thing that I can do is to then change how my data is structured a little bit. But for simplicity, for this particular first example, I'm just going to leave it as is, and I'm just going to do, whenever you want to get a particular user, I'm just going to, copy this and paste it here. And I'm going to change this to be user, not users, and then I'm going to say get a user. So how am I going to get a particular user? There are many ways. The first way is to use a path parameter. And what we mean by path parameter is that it's actually in the path of that endpoint. So we say that endpoint can, after the slash, the entire bit is called an endpoint, and you can have multiple slashes that denote different points or denote different resources in that endpoint. So one of the ways that we can denote a resource in FastAPI is using path parameter. And basically this is done this way. I'm going to just call this index because I want to return the index. I want to return an item from this particular index. This is why if you're not very familiar with Python basics, things can get a bit confusing. And I'll talk about the specific things that you need to know when working with FastAPI, particularly as when you start getting onto the query parameters and the request body, you're going to see a lot of stuff that if you are not very familiar with Python features, then it gets really, really confusing. But I hope we'll be able to untangle that mess within this session. So I want to get a particular user. You pass that as a path parameter, and then you pass it as well inside your function as a parameter. And maybe a quick question to anyone on who can access the comments, who can comment on this. And maybe Africa STEM Summit will take note of who answers this correctly. But quick quiz, someone who can define the difference between a function argument and a function parameter, please type it in. If you can quickly define the difference between a parameter and an argument as far as Python functions are concerned, please type it in. That is something that I got asked once in an interview, and I luckily had learned about it from a podcast that morning. So I do hope that members who are joining us do know the difference between a function parameter and an argument. Anyway, moving on, I am going to return my user. The user is equal to users at a particular index, and then I'm just going to return my user. So very simple logic. I'm just returning use up the defined index, and we can go back to our front end and refresh the page. So we now have a new endpoint defined with the /user. And what happens is that I'm going to execute this. So this time it's asking me for an index. So I'm going to start at index 0. And this time I'm going to get, whoops, I'm supposed to get a particular user. So this is something that happens when you are, okay, I know what has happened. When you're working with a live demo. And it's actually why I enjoy this particular talk, because I got the opportunity to do this live and to showcase how actually software development happens. And maybe not to get too philosophical about this, but most of the time when watching tutorials, you might wonder how these people know everything. And you even start questioning your abilities in terms of why you're not able to grasp all these concepts just as they have. But in actual software development, well, that is usually not the case. Usually you go through a lot of problems and you debug them one by one, and it's what we are going to be doing right now. So this is a particular error. I have tried to get a user at the index 0, but you can see I am getting an internal server error instead of getting an actual user. So I was expecting to see Stella here, but I am seeing internal server error. And when you go back to the terminal, I can see at the very bottom, the type of error that I'm hitting is a type error. I'm being told the list index must be an integer, not a string. And to quickly fix this, I will show you a manual fix, but I'll also show you how FastAPI automatically takes care of this. And I'm just going to say index is equals to index. So I am manually converting this index that we've gotten from the path to be an integer. This should theoretically fix our issue. So let me refresh and try that again. I'll be glad if we hit a different error or it works out of the box. So index 0, perfect. We do get Stella. So I've had to do manual type conversion here in order to get this data to be converted into an integer. And instead of doing this, what FastAPI allows you to do, or what FastAPI has built in, is being able to define that index that way. So I'm defining my index to be of a type of integer. And for a quick demo, and I'm not going to do this very regularly, but I'm going to do this particularly because this is one of those features that it's not very common in Python development in general, but it's the standard in FastAPI. So most even some of the Python developers might not be aware of this. But usually, when you are declaring your variables, you don't need to declare a type. So if I have the year 24, so this is how you define a variable in Python. Statically typed languages, you'd have this to be a string, and then you'd have this to be an integer, so to speak. But Python does not have that. Python is a dynamic language. However, as I mentioned before, from I believe it was Python 3.7 or 3.8, you'd have to go and do your research, but they did introduce type hints. And what that means is that whenever I'm declaring a variable, I can use this notation to define the type of variable that it is. So the full colon and then the type. In this case here, I'll put the full colon and then int. And this is also common to lists. So if I have a list of fruits, maybe apple and banana, I can also define this to be a list. And in fact, you can even go a step further and define this to be a list of strings. So in this case, I'll put a string here. And this tells Python that this is going to be a list of strings. But what you'll notice is that Python does not enforce this. So it's good that you've defined it this way, and other developers are going to infer what you meant when you did it this way. But Python in itself is not very strict and will not throw an error whenever I do this. So I define this to be a list of strings, but I put integers, and it's not going to be an issue actually to Python. But what FastAPI does is that it uses a data validation tool called Pydantic. So Pydantic is what's going to come in the middle of this. It's going to look at the type you defined and the data that you're passing, and if there's a mismatch, it's going to throw an error. So Pydantic is sort of the data validation watchguard in FastAPI. So yeah, that was a quick demo. Let me not save it, but I just wanted to explain that because in FastAPI, that is the standard. In your usual Python programming, you do not get to see that, but in FastAPI, that is something you'll see all over. And what that does is the same thing as I have done down here. So if I go back to my application, reload it, and then try to run it again, let's say try index 1. Yeah, it does work out of the box because it has been defined as an integer, and even the documentation now highlights that this is an integer. You can see here it knows that this is an integer because you did define it as an integer here. And speaking to Pydantic's data validation, if I tried putting here a string, it will throw an error. It will not even go to the backend. So it has not even pushed this request to the API because the data validation layer already knows that this is an issue. So this is one of those features that are important to discuss in FastAPI. So we've gone through the first type of parameter, and that is the path parameter. There are other types of parameters that you might have seen, and I will get to show this using even a YouTube video. Again, benefits of doing things live, you get to improvise on the go. So that was a path parameter. A query parameter usually involves having something like a question mark. So you'll see question mark and then whatever follows. So I'm just going to quickly build that, and then we'll go through an actual example from YouTube. So if I were to get a user now using, if I was to do this instead of using a path parameter and using a query parameter, the only difference I need to make is to get rid of that path. So whenever FastAPI sees this, it sees in your function you've defined a parameter, but you've not put it inside the path. It knows that, well, this is not going to be a path parameter, it's going to be a query parameter. And you're going to see the subtle difference. So whenever you run a query in FastAPI, it usually shows you how the command can be done if you are doing this from the terminal. And you can see how it actually builds it up. So it went to our particular URL, then /user/1 whenever we are querying for the first user, right? And that is a path parameter. So you get to see the type of data that you're sending after a /. But the difference between this and a query parameter is that the query parameter will have a question mark. So I'm just going to refresh this page and demonstrate this. Now we are going to get a particular user, try it out. And if I put 1 again, so remember the other one was /1, but here you can now see something different has happened. It's now going to the base URL /user, then question mark index is equals to 1. And this is usually a very common practice with APIs. So instead of defining path parameters, this is a more sort of robust way of doing things. It's very common to mix both query parameters and path parameters. That is common to see. But yeah, I can see a comment. Someone tried to define the difference between parameters. Yeah, and I think Aganyo got it. Aganyo compilations got it first correct. That's the first comment that I'm seeing that answers the question. And Edwin as well got the question. So yeah, kudos to you guys. If I was doing a Python entrance test and you are working or you are getting into my organization, then you would have passed that particular test. I am seeing a comment from Crystal to enlarge my screen. Unfortunately, with this particular screen, I cannot full screen it. Maybe just enlarge it a bit. Oh, this actually makes sense. Thank you for that. So this is what I was talking about. We have the base URL, we have the actual endpoint /user, and then because this is a query parameter, we have the question. So question marks for queries. Queries are questions passed to your endpoint. So this is common for simple API things, simple API tasks such as getting a particular user by ID, for example. But what we want to do is to discuss a request body. And this is usually when you want to pass in data to your API. And the common example about this is during user sign up, you want to be able to take in all the data from that user, whether it's an image for their profile. You want to also get information about the first name, last name, email, password, etc. etc. So whenever you want to pass in a chunk of data to your API, you do not use query or path parameters. You do use a request body, or you put that as part of your request body, and you're going to see how that works. And I have been mentioning Pydantic from time to time. Now this is the point where we actually get to see Pydantic in action. This is the structure of an API request. So we have the URI, or the URL in this case, and then we have the method that we are passing to that endpoint. And then we usually have headers. If you are very keen and you come to this first API, if you get to look at this, how this request was sent to the actual API itself, you can see that it sent a GET request, and it sent the GET request to this particular endpoint. And then it also sent a header. So if you look closely, you see this -h, which stands for a header. And usually headers are sort of metadata about that particular request. So if we had built authentication around this API, so being able to sign in and sign out, that is information that usually pass through the header. You might have heard of cookies. Whenever you go to any site nowadays, you have to accept cookies or decline cookies, and that information is usually passed via the headers. And just out of curiosity, if you are wondering why every website nowadays does ask you to accept or disallow cookies, is because it is an actual requirement by GDPR, the General Data Protection Regulation. So it is a set of rules set by the EU or the European Union in guiding how content on the internet is consumed, and basically to protect users and to enable you to not be uh, for your data not to be tracked all the time. So they do have to allow you to opt in or opt out, and that is one of the reasons why you get to see uh, those cookie questions whenever you visit a website. Anyway, now that that is in order, we can actually build a more complex URL. So in this case, I'm going to use a post request to add a new user. So I can minimize all this or just collapse them so that our focus remains on this post request. So I want to add a new user, and one of the things that I can do is to pass in a user object. So how do I want the structure of that user to be? And I am also going to change this data structure so that we now have a more complex representation of what can simulate what's in the real world. So allow me to make a few edits to this object. Oh, and by the way, VS Code does have this feature where I can use multiple cursors. Do that, then I can do that and close this. Oops, that did not work. Close this, make a lot of sense. So this is my new construct. So that is ID1, ID2, ID3, and ID4. So now my list of users is a dictionary. It's a list of it's a Python dictionary where every user not only has a name but also an ID, and I can go on to construct even more things about this. I can add maybe the date of registration, for example, in this particular application. So I'm just going to maintain this for its simplicity and then go right on to defining our data model. So I want, whenever you are passing your request to the post, whenever you're pushing your data to your post request, and I can enlarge that post request, which is here. I want you to be able to put in that ID and to put in the name of the user. And that is what I'm going to define, how I want my data to be represented or to be passed on to the API. And usually do that using Pydantic. So I'm going to import Pydantic, so or a tool from Pydantic, Pydantic import base model, and then I'm going to create a class. So one of the things that you need to know, point number 2, things that you need to know when working with FastAPI. The first one was type hints in Python. The second one is object-oriented Python. You're going to be seeing this a lot. So our user, and it inherits from the base model. This is basic object detection stuff, and then ID, I'm going to define it as an integer, and the name, which is going to be a string. That's basically how to define a data model using Pydantic. So you inherit from the base model, which is provided by Pydantic, and then you define your variables as well as the types, and this is using Python type int annotation. So going back to our post request, here we do have our post request. I'm going to now say I am going to expect a user. I'm defining a new variable or a new parameter called user, and it's going to be of the type user. And maybe to make things not very confusing, user data model. Let me just refer to this as user data model and have it here as user data model. So whenever FastAPI says that you have defined a Pydantic model as a function parameter, it knows that this is automatically going to be part of a request body. So what I am going to do is, once we have that, I can try to do a quick, I don't know whether this will work actually. So this is a Python list. I'm just going to add on to that list. So users dot append, and then I'm going to use that actual data object. And by returning users, you're going to be able to see the actual user being returned. So let's go into this, refresh. And as you can see, even the documentation is now reflecting that this is the type of data that it expects. So if I press try it out, and then I now have access to the request body. I can add my own ID. I don't know where we are. This was 1, 2, 3, 4. I can add my ID 5, and name, this will be, all right. So whenever I press execute, I do expect that when we come here to our response body, we have various data that we had in the list before, but we now have a new data construct added there. And that basically is how to use a request body. So we are actually done with the differences between the types of parameters that you can pass on to FastAPI and the types of requests that you can make in an endpoint, which summarizes basically the first part of this demonstration. The next bit, which is a bit more focused on a real app, is basically being able to connect a real database. So I'm going to go a bit faster over that particular section, but this is what I'm talking about. We're going to be talking about database integration. So right now we're just working with a simple list, right? we've constructed our data here, and this is temporary. Every time we refresh our page, we lose access to the new data object that was created. But our database enables us to store that data permanently. So yeah, we now have gone to the section where we need to discuss databases, and in the database world, there are many types. There are SQL and NoSQL databases. And then we are going to discuss a concept in databases called object relational mappers. And the example of object relational mapper that we're going to use is called SQL Alchemy. And there's another one called SQL Model that is built on top of SQL Alchemy. So right on to SQL versus NoSQL. I'm not going to go into the nooks and cranny of what SQL and NoSQL databases are. I'm just going to discuss the examples of SQL and NoSQL databases. And I am hearing myself talking too much about SQL and NoSQL. So here's another thing. When you go to the internet, you'll find that there are various pronunciations for these terminologies. The first one is SQL, what I've been using. Other people just refer to this as SQL versus NoSQL. And one particular funny one that I came across about a month ago is squeal. There are people that pronounce this as squeal. So squeal versus NoSQL databases. So whatever makes you excited, you can use that. So example of SQL databases are MySQL, PostgreSQL, SQLite, SQL Server. And examples of NoSQL databases include MongoDB, DynamoDB provided by Amazon AWS, Redis, and Neo4j. So when you go down the rabbit hole of NoSQL databases, you'll find that these are actually different types of NoSQL databases. So MongoDB is considered to be a document database. DynamoDB is considered to be a key value store, same as Redis. Neo4j is considered to be a graph database. And when you talk about graph databases, you might come across things such as GraphQL, which is the type of API. The type of API that you're currently working with is called a REST API, a RESTful API. So we are going to be using this typical HTTP methods. These are the types of APIs that we used to, but GraphQL APIs are slightly different. Usually have just one endpoint with one method, which usually post request most of the time. And they're pretty exciting in terms of how you get to interact with them. But well, that is subject to another discussion. And I'm also aware that there will be a talk about SQL and NoSQL databases. So yeah, this maybe might serve as a good introduction to that later on. And moving on, we do have things called ORMs. So an ORM, or an object relational mapper, from this particular diagram is that an ORM enables you to write Python code, and then the ORM itself is going to convert that Python code into SQL or into SQL. So you're not going to be writing raw SQL. You might be familiar that SQL in itself is a language used to talk to databases, but using an ORM abstracts that away from you. So you don't need to start learning SQL again. All you need to do is just to learn how to use the ORM, and it's going to go back in the backend and convert all that Python code into the particular SQL statement. And ORMs are common in every programming language. Java has its own, Python has its own. All manner of languages have their own ORMs. So now the question becomes, why would you use an ORM? Why not just learn SQL, right? And the first thing is abstraction. And abstraction means it's getting rid of you having to write that SQL code. And a good reason for that is that SQL is very tricky. And it is very simple, but it's deceptive in its simplicity. And if you do not be very careful about the types of queries that you write, or the types of even characters that you write, like for example, in SQL, the backtick is different from this single quotes. So if you use a backtick in place of a single quote, you might end up destroying your actual database. And since SQL talks directly to the database, you want to be very, very careful in terms of what you are doing with your database. So using an ORM abstracts that away and ensures that you're not writing dangerous SQL code. The next thing is portability. Whenever you have an ORM, and I'll focus on this diagram, you just write your Python code once, and you can interchange your databases. So you can switch from a MySQL database today and use a PostgreSQL database tomorrow without having to change the actual commands, because SQL is also custom to the various databases. Different databases have different features, and as far as that is concerned, SQL also slightly differs across databases. So whenever you have an ORM, the ORM is going to do that hard work of knowing that, okay, you're now connecting to a MySQL database, this is the type of command that I should be sending. Or you're now connecting to a MySQL database, this is the type of command that I should be sending. And maybe a quick point to clarify is that ORMs are used for SQL databases, and SQL databases are relational databases. That's why this is called an object relational mapper. So they are used for relational databases. Um, for NoSQL databases, there's a different way of handling things, but we won't go into that because we are going to be working with a SQL database. So yeah, portability allows you to quickly switch over different databases. And then productivity, you have basically focused on Python solely, or whatever language you're working on. That is how I'm defining productivity in this case. And the final bit is security. What happens by using an ORM is that it automatically does the sanitization for you. Usually when someone puts in you might have heard of a type of attack called SQL injection. And it's basically whenever, let's say, someone goes to YouTube and inside that search box, instead of searching for a particular video, they are malicious and they want to search for, they put an actual SQL query. So they might say something like, select all users from the database. So that if YouTube did not have this sanitization in check, it will basically return all the users from their database. So this is something called SQL injection. You might want to read more about it, but by using an ORM, it does that sanitization for you, and that ensures that out of the box, your API is one level of security better than having to write your own custom SQL code. As I mentioned, I'm going to be supercharging through this section. And first thing that I'm going to do is we are going to make this look a bit more like a real API. And by real API, I mean you usually do not write all your code in one file. I believe in all your projects, especially the more complex projects, you not get to write code in just one file. You get to split the code. So the first thing that we usually do is that we keep all the pedantic data models in a separate file. So I'm going to refer to this as schema.py, and I'm just going to remove that from there, put it here. Take again my data model, put it there, and then I can now say from.schema import data user data model, and this will ensure that we do have access to that user data model in our post request that we were using. So that is the first thing that we should do. We split up that, and then now the code that goes to the database is also in a different file. So we are not going to be putting everything in the same file. So this is db.py. And as I mentioned previously, the type of ORM we're going to be using is called SQL Alchemy. So we have to install that as it does not come by default. So I'm going to do pip SQL Alchemy. As that is going, I'd want to continue building onto this. Okay, so and this is a particular section in which even I myself, even though I've written multiple APIs, I have not mastered or had at the tips of my fingers. This is something that I'm actually having to look up as I go. So it is not as straightforward as, well, it is not as straightforward for me at least how to go about this. So usually all the time that I need to create to the database, I just get to look at a particular code definition elsewhere. So that is what I'm doing. So Alchemy, and these code examples are also provided in the FastAPI documentation, and FastAPI documentation is one of the best out there. I think clarity. Whenever you're using a tool and you declare, I think I cannot speak and type at the same time. But whenever you're using a tool and you have access to legit documentation, supercharged, it makes your workflow much easier. And FastAPI so far is one of those tools that has benefited from having extensive documentation. And it's so nice that most of the time you not even need to go online to look for different tutorials. Just using the FastAPI docs, you can be able to actually work with FastAPI. So the next thing is defining where the database is connected. So you are going to see something called SQL Alchemy. SQL Alchemy database URL. Some people call this a URI. And we're going to talk about the syntax of this a bit, but I'm going to go ahead. We're going to be using a SQLite database. It's very possible to switch this up with a Postgres database or to use a MySQL database. So there is no inherent preference for that, but we will talk a bit about why SQL in this case and why not SQL maybe in a production setting. So first thing is this. This is a weird construct right here, and basically this is what tells SQL Alchemy that I'm going to be connecting to a SQLite database. So whenever you're connecting to a Postgres database, you're going to switch this string up into something that SQL Alchemy will know to be Postgres, and this is also defined in the SQL Alchemy documentation. But again, FastAPI has already documented this again on the site. So that is something to note. That is something new. And then here is just basically the path to your database. And this part is slightly different for other types of databases such as Postgres and MySQL. So if I can just do a quick demo of how that will be if you're using Postgres, and this is also going to be the same if you're using MySQL. Now they have 2 slashes instead of 1. And then I can just get rid of that entirely. Usually the structure is the username. In this case, most Postgres databases have Postgres as the default user. And then the database DB password at host name. So if it was built on your local computer, if the database is currently in your local computer, you just put localhost or 127.0.0.1. And then host name, do you declare port? I think you do have to declare port here. So in the case for 5432, that is the port that is the default port for Postgres, and then the database name. So as you can see, the structure is slightly different for Postgres, MySQL, and other types of relational databases. That is not the same for SQLite. Moving on, we now need to create the database engine. We provide the database URI, and then particularly for SQLite, you do have to add these parameter connection arguments, and it's basically around how SQLite works. So check. This is not something that you do to other databases. And then we are almost done, just 2 lines of code left, and we can start looking away from this. This is usually, let's say, the most gruesome part of this. Session maker, and then again some default parameters. and then base is equals to declarative base. So we are done. So I did define this wrongly. Let me ensure that they are the same. Perfect. I'm hoping this is a bug and will just go away, so we'll get to see if that runs or not. Oh, it is actually how I define SQL Alchemy, so that should be okay. We are done with that part of the database. We are not completely done with databases. Just in the same way as we defined a data model, we are going to define a database model. So this is how we want our database to be structured. And I'm going to create a new file here. Save it as models.py. So this is separation of concerns. I could have put all this code in one file, but I'm opting not to. For a good reason. Big apps usually have a lot of code and you usually want to separate things out as soon as you can. So I'm going to be creating a table inside my database, and this is how we do it using an ORM. And in this particular case, I am using SQL Alchemy, so I'm going to be doing how SQL Alchemy does it. So I do need to import, in the same way we did import base model from Pydantic, we do need to import that declarative base that we defined here. So I'm going to import this base from DB. So import base, and I can now start again. We define this as a class, so I can say user DB model just to keep things in check between the difference between a Pydantic model and a SQL Alchemy model. And this is one of the things that gets confusing when you're working with FastAPI, how to distinguish between the Pydantic models and the database models. So we're going to do that as base, and then the other thing to define is a table name. How do you want this table to be called? And in this case, I'm just going to say it be called user, and we have the ID and the name. So how we define these columns, remember a database at the end of the day is just a collection. It looks exactly like an Excel spreadsheet. So you do have your columns, so that will be your ID and name, and then you have the rows, the actual data. So Stella, Lenny, and all the rest are going to be defined as rows. So how do you define a column in SQL Alchemy? And I'm just going to do that from SQL Alchemy import column. So I'm going to say that the ID is a column, but you need to define the type, just as we did define the type here. We're not going to be using type int annotation. SQL Alchemy comes with its own types. So I'm going to have an integer type and a string type. So we have our column is of type integer. And in this case, I'm not going to necessarily need to pass in the ID. If I set this to the primary key, if I set that as a primary key, it's going to be auto increment. So I only need to pass in the name, and then SQL Alchemy through that definition is going to be auto incrementing the ID. So I do not need to know where we currently are. We are at ID 5, so I add ID 6. SQL Alchemy is going to be doing that for us. And it's been a while since I've checked the comments. Can see a question from Christopher on how to hide keys for databases. Sure, we're going to be talking about that in the upcoming slide. So name is equal to column and then string. And we are done. So the next thing that we'll need to do is to just go to our main.py and now start using this model. You can get rid of the terminal so that things are easier. I can also maybe get rid of, I will not get rid of this because it will break a lot of things, but I can start ensuring that we are not returning this list, we are returning data that is actually in the database. Right now, we do not have any data in the database, so we do not expect this to return anything, but we are going to be validating that by importing things. So the first thing that I need to do is to import the models. from dot. And this is basic Python syntax of how to do relative imports when you use dot. So if the models if the models.py was stored in a folder outside this, I'll just do from dot dot, and then obviously you can be able to go up the parent path of the folder structure. So this is relative imports. So I need to import my models, and for me to be able to create that actual database and to create the tables within the database, I just need to do models.base dot metadata dot create all bind is equals to engine. Again, this is something that I'm having to look up. I have not mastered this atop my brain. So I'm going to do that, and then obviously I need to import the database, and I need to import from.db. I need to import the engine, and I need to import the session. We're going to see where this is applied in a minute. But once you run this code right now, it's going to actually create that SQLite database, and we are going to see it appear here. So in our file structure, we'll see a new file called, what will it be called? If we go back to our DB, it will be called SQLapp.db. We are going to see SQLapp.db here once we run that code. But we are not yet to the point where we can run the code. A few more things that we need to do, and this is an advanced concept. In FastAPI, we use things called dependencies. Maybe I can get rid of that so that we can be able to see things clearly. And in this case, we're just going to create a function that anytime it's called, it's going to return that database object, so that we can do things like db.getUser or db.addUser. So we want to have a function that gives us that database session, which is why we even imported the session local, as you will see. So get db, db is equals to session local, and here it's defined as a generator. So you might want to read Python generators to understand what this line of code is doing. We do not expect any. This ensures that we have a fresh session every time. And again, this is also defined in the documentation. No need to worry much about this. You just need to worry about how to implement it in your code. So the first thing that we're going to be doing is that we need access to this database session, and we can get it through this getDB dependency. So how do we go about that? We just need to say that we are expecting a DB object, and it's defined as a dependency. So that's why we use depends, and the actual function is getDB. Now we do also need to import depends from FastAPI, and that gets rid of the error. Now, what type of data we expecting? You can see from the various other parameters we did have type annotation. So in this case, we also need to do type annotation for this, and expect that this is going to be a session object, and we do need to import session. So SQL Alchemy does come with its own types, and this is what can get confusing between SQL Alchemy and Pydantic. Having to be able to work with the two of these things at the same time can get really, really confusing. So now my list of users, or I can just call it DB users so that we do not confuse anyone, is equals to DB dot query. And then we have to call this database model. So again, I have to go up here and say something like, oh, since I've already imported models, I can just do this models dot user DB model, and you can see VS Code autocompletes that because FastAPI has built-in support for this editor.org. So what this does is that it's going to write Now SQL Alchemy is going to write the actual SQL code that says select all from the user table. I do not need to call the user table, I just need to call the user DB model. SQL Alchemy is going to do all the other hard work. And for a more complex application, it will make sense why you'd use an ORM. Right now, it might not seem very useful in this particular simple example, but I'd like to run this. We've been writing a lot of code. I'm even doubting whether this will be able to run. Okay, it fails. So from .schema. Okay, this might be because whenever you're importing things in Python, so we need to have something, and you might have seen this elsewhere, init underscore underscore .py. It's just an empty file, but it now tells Python that this particular folder is a Python package, so we can be able to import things from it. So I'll try that again. Woohoo, it has worked. And as we mentioned, we are going to be seeing this SQL app.db, and it has been created, so I do not need to look inside. All I need to do is to go back to my FastAPI application, reload the page, and try to get all users. Right now, I expect an empty list because, again, the database does not have anything. But right now, we are pulling data from the database, which is something pretty cool, and I hope this runs. Whoops, we are getting a list of users. Oh, and that is because we are returning users. So again, even with all my experience with the 8 years that I've been coding, I still do make simple mistakes. So don't beat yourself up too much if you find yourself making mistakes. So I was returning these users instead of returning the actual DB users from the database. So I'm going to go back here, refresh the page. Now this time round, I expect that we will get an empty list because there is nothing in the database. That is perfect. All right, there are no comments at the moment. I hope everything is okay. So I'm going to look into just adding something to a database, and then we can call it a database session. So I'm going to get rid of that. So just as we're using this to get all users, I'm not going to focus on all these other endpoints. I am going to publish this as a GitHub repository. So if you want to go and download this and try to convert these endpoints on your own and connect them to a database, well and good. That is something that you might want to do. So I'm not going to focus on all the rest. I'm going to focus on post so that by the end of this session, we are able to read users and also to get users. So first thing that I need to do, I have defined my data model, but I also need to have this database session to be passed to this function. So it is of a type session. It is a FastAPI dependency, and you need to go read more about dependencies to see why we need them. And the actual function it depends on is the getDB function. So the thing that we can do here is just do something like db dot add, and what you're going to be adding is the user. I am looking this up as well. This might actually not work. What we need to do is to unpack this. So I'm going to say db user is equal to, we know that it's going to be a user data model, but we might as well unpack it. It's going to be a user data model. The actual user object that was passed. This again is standard Python dot model dump. And what this does is that it's going to take the ID and define it as, and it will take the ID and match it to the ID that was passed in. It will take the first name and match it to the first name that was passed in. Basically, it's just taking that data and matching it up to what we have. That is what this line of code does. So it is taking our user object and matching it to our user data model. As I noted in the past, we're now no longer going to need this. So I'm going to comment it out because we defined it in SQL Alchemy as a primary key. and that means it's going to be auto incremental. So it's going to be added every time we add a new user. So right now, the only thing we need to pass in is the name, which makes it slightly easier. But you can imagine if this was more complicated, it would still work the same way. If we had a birthday in there, for example, or we had the date of registration, for example, we'd also simply add on to this list or schema, and then obviously add in the corresponding database columns in our models.py file. So db user, I'm going to add that user to the database, and then what you do is db.commit. Usually you run db.commit whenever you changed something in the database. So when you're updating a user or you are adding a user, you're going to do db.commit. And then it's also very common to see db.refresh, just so that we are working with the latest data that has already been added onto the database. And what I'm going to return is that new object that has been created. So I hope this works right out of the box. Let's refresh this. And it might seem like there's a lot of information right here. It is true there's a lot of information. Databases are things that people take time to get used to. If you're particularly new to this, I'd not worry too much about being able to do this on the first go. Usually it does take some time before you actually get to know how to interact with the databases. So I'm going to try this out. I'm going to add a new user, table, execute. Whoops, internal server error. Let's go in there and debug. So it does say that the user data model is not mapped. And that is because I'm not supposed to be mapped. This is already mapped to the user data model, the Pydantic model. I'm supposed to be mapping it to the actual DB model. So that is another instance where I messed up the different types of models, and I need to import that. Or because I already imported models, I can just do something right here. Models dot user DB model. So refresh the instance again. And as I mentioned, it is particularly confusing when you're working with Pydantic and SQL Alchemy. Sometimes you do get to mix things up, but the errors that are thrown by FastAPI are relatively readable, and so you're going to be able to immediately know what the problem is and get to fixing it. So let's try that again. Able, execute, and right now we have able and the ID was automatically incremented. That is perfect. I am going to add a few more users. Let me just pull up the comments again. Crystal, execute. Crystal was added. Maybe Christopher. Execute. Christopher was added. And as I mentioned, since our get users is connected to the database, if I try this and execute it, we should see the 3 users that we've added. Perfect. We do see Abel, Crystal, and Christopher. So that is what it takes to work with a database. I think the other more challenging thing to do when it comes to APIs is being able to build authentication. So in that section, we're not going to be working with code. So that ends the bit about code. So right now we're just going to be discussing and talking through the various other things that work to be able to implement an API. So authentication and security, that is the other section that we have to talk about. And the first thing is the authentication methods. There are multiple types of authentication methods that you're going to see around the internet. Obviously, the most common is the basic username, password, HTTP, basic authentication. And when we're talking about authentication, it does get important to know that when we are talking about this in the context of APIs, it's a bit different from the context of, let's say, web applications. Web applications, when we talk about authentication, most of the time we're just referring to being able to implement that feature where a user inputs their username and password and they're able to log in. But with APIs, we are talking about this from a step further. And those of you that have interacted with APIs out there, you know that when you sign up for an API, you usually get an API key. So that is one of the authentication methods that is employed in a particular API. And my second question. So the first one was the difference between function parameters and queries. The next question, and I hope someone different can be able to answer this, is the difference between authentication and authorization. Those two things get interchanged, and that is wrong. They are different, and I'd like to see someone in the comments be able to shoot that up as fast as they can. The difference between authentication and authorization. So I'm going to go into authentication methods, and the most basic one is auth. Auth is an authentication standardization, and uh, the particular protocol that is supported by FastAPI is called auth2, and auth2 enables you to integrate services like Google, Microsoft, GitHub, etc., etc. And this is and everyone has gotten exposed to this. Whenever you go to a web page and it asks you to sign up, you can either sign up using your email and password, or you can sign up with Google, right? So that feature or that functionality of being able to sign up with Google or Microsoft or GitHub is what we refer to as, or is what is implemented as auth2. So FastAPI does support this natively. You do need to do a bit extra, just like we did with the database. You do need to do a bit extra on the database as well as on the code side so that it can be able to support that. But it is natively supported by FastAPI. We also have JSON web tokens. These are very common in API development. Whenever you hear someone talk about JWTs, or other people pronounce them as JOTs. I don't know why, but they are an authentication method that is used when working with APIs. And then being able to implement the API key. So API keys they usually work hand in hand with JWTs. Yeah, so basically implement a JWT for a particular API key. And this API key has a certain role or has a particular level of information it can access. So think about this from a user role perspective. If I'm a normal user, I'm just going to be able to see the normal data. Let's say in YouTube, I'm just going to be able to see the videos, right? If I am a channel creator or I am a person with a YouTube channel, I can not only see the videos on YouTube, but I can also see a particular page that is dedicated to me to manage my channel. So this will include the videos that I've created and the videos that I've added onto my playlist. And if I am a developer at YouTube, I'd be able to see all the code and even talking about putting the code aside, I'd be able to see, let's say, all the users inside the platform. Right now, you as a user cannot see all the other users, but as a developer, I do have access to that. So this is a form of user role authorization, and it's what you can be able to implement. You can implement the exact same thing using API keys and JSON web tokens. Oh, and another thing, JSON. It's actually not pronounced as JSON. So this is JavaScript object notation. That is what JSON stands for. And we all refer to this as JSON, but the actual creator of JSON recently put up a video on YouTube pronouncing how JSON should be pronounced. And believe it or not, you're actually supposed to pronounce it as JSON. So put a particular French articulation to it, and that's the pronunciation of JSON. The other thing is API security. So this is a topic that is often overlooked. So the basic things that you use to, or the bare minimum that you can implement at least for any API that you work on, and you should try to do this even for your personal project so that you get in line with what the industry expects, is implement authentication and authorization. Those are different. And I'm just reading through a comment. I am reading through a comment of someone who's trying to define the difference between authentication and authorization. And Kanji, I believe you are in line with the right answer. I'm not going to say it is correct 100%, it is correct 90%. There are just a few details that you're missing out, but yeah, you are in the right direction. All right, so apart from authentication and authorization, the next thing is to enable HTTPS. So you might be aware there is HTTP and HTTPS. And whenever you go to any site that has this padlock, it means it has HTTPS, and that is enabled through something called an SSL certificate. And there are free services to do this. You'll get to see this in the next slide. The other thing that you can implement, though is not very mandatory, is rate limiting. Sometimes you'll find that when you publish an API to the internet, there are bots online that target your API and they send requests every second, every second, every second. And you might find that if your particular API is already deployed on a cloud service such as AWS, your bill goes exponentially high because you are charged for the number of requests, obviously based on the services that you've selected from AWS. But without implementing rate limiting, your API will be severely abused. I have had experience with this even uh, with the company that I'm working with at the moment, and we were able to get to the bottom of this because we implemented a few more security layers, and so we are able to even block IP addresses or block geolocations that we not want our API to be exposed to. So those are some of the things that we can talk about. The other thing is input validation. Already, Pydantic takes care of this for you, so you don't need to worry much about this, but it is important that you use Pydantic data validation as well as SQL Alchemy's sanitization so that you protect your database as well as your API from having attacks such as SQL injection, for example. And the other important thing, which is really a lot of work to do, is usually log auditing or being able to add in logs. So by logs, I mean whenever anything is happening in your API, you need to be able to see what has happened, who has visited what route. And if we take a look at the terminal here, you can see anytime I make a request, you can see that there is a get request to the Open API JSON spec. This is what Swagger UI does. There is a post request to the users, which is what we are testing when we are adding our 3 users, and there's a get request when we're looking at all the users in our databases. So you should be able to save this log somewhere, either in a database or in a text file or in a log management service. And this is so that you can be able to come back at the end of the day and investigate whether there is something fishy going on. And this is actually one of the ways in which, at my current role, we were able to detect that there were bots that were targeting our API, and we were able to successfully block them out. So log auditing is something very important that you get to see in practice when you are live in production, but maybe not so much when you are doing your own development. But it's something to mention when you're working on production level APIs. There are a lot more features of FastAPI that we did not get to talk about. For example, dependency injection. We just mentioned it when we were talking about the database having being a dependency in FastAPI. There's actually an entire topic about dependency injection in FastAPI. And for information, all these subtopics that I've listed here can have their own 2-hour talks. That's how complex they can get, and even 2 hours will not suffice to completely do them justice. So there is a lot more that you can learn. There is a lot more that FastAPI provides. As we mentioned in the beginning, it is production ready and it is very fast. So all this support, for example, for logging that I was talking about, it is built natively into FastAPI, and it makes it very easy for you to be able to connect to maybe an external log management service so that you can be able to see your logs, right? So and the other thing that we did not even talk about was error handling. So all this time, whenever we faced an error, we just saw 500 internal server error, and then we went back to the code and looked at the terminal, and then you're able to see the error. But when you are working on a more complete API, you'd want to give your users better error logs or error information or error messages. So you tell them something like database has failed, please contact administrator, or just say please contact system administrator. If you face maybe a data validation error, you need to tell your users through an API response that the data that you've input is not of the format that is expected. Please put a valid email address, for example, in case someone put in an invalid email. So how do you handle for these different types of errors, and as well as following from that, how do you convey the appropriate type of messages when you are working with your API? So that is another thing that FastAPI has built native support for, and does make managing errors very, very easy for you. Final bit is on deployment and scalability. So we now built our API. How do we deploy it? On the left side of my screen, I have put in the deployment side of this discussion, and on the right side, I've put in the scalability side of this discussion. So, starting from the left, when you finish up building your API, you'd want to deploy it on a cloud service. So, most platforms or the most popular platforms are things like Amazon Web Services, AWS, Google Cloud Platform, GCP. We have Microsoft Azure, Linode, DigitalOcean, and they're basically endless cloud services nowadays with different features, different pricing models. So there are even cloud platforms that allow you to deploy for free. So you might want to check them out so that you can be able to have your own API deployed on the internet without paying anything, because AWS, well, you're going to have to pay a lot of cash in order to get to use some of these popular cloud platforms. But they do exist free platforms. I've just forgotten one that I was thinking about. But anyway, a quick Google search will bring you to that. And whenever you are deploying on, let's say, AWS, you do need to deploy your application inside a server. And instead of building your own server, so right now we are using the server that is provided by FastAPI, and it's what's serving this demo application, right? So in a production environment, you'd use something like Nginx or UVCon. UVCon is supported by FastAPI. Nginx is supported by FastAPI, and it's more popular. So I'd go for Nginx, and it's what I've been doing over the past few years. Whenever I'm deploying something, I deploy using Nginx to get your SSL certificate so that you can be able to have HTTPS instead of HTTP. You can use a free service called Let's Encrypt, and Python does have a module called Certbot that will automate the getting of this certificate for you. So you just need to run a few commands following the documentation, and at the end of the following these instructions, you're going to have your own SSL certificate that is automatically renewed, because it needs to be renewed every 1 or 2 years. That is automatically renewed, and every time you visit your deployed application, it's now going to have a HTTPS uh, URL instead of a HTTP. So free service, make use of it. Docker, as I mentioned, has come to save the world, particularly very common with the DevOps people, so the people that are working in the development and operation side of things. And usually with Docker, it takes care of this mess that we have when creating environments. So instead of, for example, the current environment that I've built right now is working on my Linux setup. And you might be working with a developer who's on a Windows laptop, right? Or you are deploying on a Windows server. These things happen, and some of these dependencies are not particularly supported on Windows, or are not cross compatible across these platforms. So having this virtual environment is actually going to be erroneous, or it's going to be troublesome when you are working in a cross-functional team. And Docker does get rid of this, because it builds the entire environment right from the operating system level. So if you have built an app that runs on Linux, it's actually going to create a container that has Linux as its base image, or as its base OS in this case, and everything on top of that is going to run, whether you're on Windows or Mac or Linux, it does not really matter. Docker does have that standardized, and when you get into research about Docker, you're going to find that nowadays a lot of even junior developer roles, if you try to get a junior developer role, one of the things they ask is proficiency in Docker. So you might want to have this as another tool under your belt. It's as useful as being able to know Git and GitHub, being able to work with commits and pull requests and GitHub issues. So knowing your workflow around that is just as important as having Docker as one of your tools or one of your skill sets. CI/CD, basically, whenever you are writing code and you push onto GitHub, you want it to be automated and to find itself in production. So you not want to, once you finish writing code, you not want to go again to AWS, start configuring servers, run your Docker containers again, and then having that display to the internet. You want that part to be completely automated. And that's what CI/CD means. It's continuous integration slash continuous delivery. So with continuous integration, you're going to be writing tests that ensure that whatever code you've added does not break what is currently working. So test is another topic that we might get to talk about next time. And by implementing this test, you ensure that anytime you push code onto GitHub, for example, these tests are running. And GitHub does this using something called GitHub Actions. It's an example of a CD workflow. You might have had more popular ones such as Jenkins, Circle CI, Travis CI. All these are CI/CD platforms that you can use in order to automate out that part of being able to push code and immediately seeing it on your production setup. When we discuss talking to scalability, the first thing that we would add is something called database migrations. So, and that is one of the disadvantages of SQLite. As far as I'm concerned, the last time I checked, SQLite does not support database migrations. So you might want to stay away from database migrations in a production level database, because what migrations enable you to do is that they enable you to work with dynamic models. So, for example, we have already defined this user database model with an ID and name columns, right? We might want to add a birthday column to be able to track users' ages, for example. And if we were to do this on a SQL database or on a SQLite database, just natively by adding a new column, it will not reflect. You'll have to destroy the entire database and then recreate it with a new data model. This does not work in production because you already have data inside your database that you do not want to delete. So you cannot obviously purge the database and then recreate it again with the new models. So usually what database migrations enable you to do is that you're going to be able to edit these user data models and continue running it like nothing ever happened. And you're going to see that new column appear like magic. And one of the tools that is used to do that is called Alembic. FastAPI does have support for this. If you are coming from the world of Flask, Flask has something called Flask Migrate, again, built on top of Alembic and does the same thing of being able to do the database migrations. Last time I checked, SQLite was not supported for migration, so that's why I always stick to MySQL or Postgres whenever I'm dealing with databases. You might also want to have a caching layer so that the frequently pulled data does not get pulled from the database all the time. It's cached in between a layer, such as one of the tools used to do this is Redis. There have been recent political squirms about Redis being taken out of open source, but that is aside from our discussion. But Redis is an incredibly powerful tool. You can also use it as a database, by the way. As we mentioned, it's a type of NoSQL key value store. So you can use it to implement caching, and it's also usually in some instances used to store cookies. So whenever you're visiting sites and there are cookies that are tracking you, usually it's a Redis instance that can be used in that place to keep store of that. Content delivery networks or CDNs, you might visit a website and then you see Cloudflare popping up and saying something like validating this traffic. So Cloudflare does support. Cloudflare, by its nature, is a content delivery network that support being able to store things like images from a CDN perspective, so that whenever you need users to pull images, for example, if you're using a site which is image intensive, such as Instagram, for example, you do need to have a CDN because it's going to take unnaturally long to load all these images from whatever store you've placed them in. So usually you put them in a CDN so that whenever users want to interact with images, they just pull directly from the CDN instead of having going to be pulled back from whatever data store you stored it. The other thing is a load balancer. And when you're deploying, by the way, in production, you might not deploy just on a single instance or on a single server. You might deploy the same API across 10 different servers, depending on how much traffic you expect. And Nginx does have support for Nginx by itself. Not only works as a server, but also works as a load balancer. So that is one of its incredible power. But AWS also supports something called the AWS application load balancer, and that allows you to be able to balance the load between the 10 different servers. For example, if you are getting too much traffic, you distribute some traffic to server 1, some traffic to server 2, all the way to server 10. And the benefit of having load balancers, especially from an AWS perspective, is that it is dynamic. So whenever your traffic shrinks, it's not going to keep all the 10 servers alive. It's going to kill, let's say, 8 and remain with 2 servers. And whenever your traffic scales up again, it's going to scale up the resources. So you have this dynamic resource allocation, which is very, very powerful and saves a lot of cost when you're in production. And then the final bit is load testing and profiling. So there are tools that will enable you to simulate, let's say your API would behave when it was attacked, let's say, by a million requests. So how would you expect your API to behave when there are 1,000 users actively probing the API versus a million users actively probing the API? So you do have that, and then profiling entails being able to investigate each endpoint and being able to see which endpoints take the longest time. So if you're building a very fast application and you want everything to be instant, you do want to look at the bottlenecks. And one way you do that is by using profiling tools. Python does have a few, and there are many more, and even paid for tools that you can use to be able to profile the code and be able to see, okay, this endpoint is taking long because there is this code that goes to the database that takes long. So you can be able to investigate, okay, why is this line that is querying the database taking long? Is it that we have too many records in the database and we need to have a caching layer or something? So being able to profile that is usually very handy when you are looking to optimize your code. And that brings me to the end of this session. So we are going to have a Q&A session right now. You can feel free to reach out. Those are my contact information on screen. And yeah, it has been quite the session. This is my first talk in which I have taken 2 hours. Most of the other talks that I have been invited to usually last 10 to 30 minutes. So when I asked about my time allocation, I asked for how many minutes, and I was told there'd be 120. I was pleasantly surprised. So I really enjoyed this session. I am feeling tired already, but coding is something that I can do all day, every day. And when it comes to sharing the knowledge about coding, that I can do even all year. So I'm very, very happy to kick off this session from Africa STEM Summit. And I'm very glad to have had an active audience that has been able to answer my questions. So I hope you did find this insightful. I'll hand it over to Stella, who will direct the Q&A session. And maybe after Stella talks a bit, we can start with the first question that I got from Christopher while having this presentation, in which he was asking about how do you hide keys. So yeah, I'd like to pause at that and get back to you, Stella. Thanks, everyone.
Hello. I actually was to read out that question. There's a lot of Joseph has told you nice session here, awesome session. You had an audience from the UK, some from Kiambu. So somebody asked, will there be a video recording? Yes, this is streamed on YouTube, so you can just go on YouTube and you can share, you can rewatch, and you can also download, I think, to your YouTube page, and so forth and so forth. So I think the only question we have, unless anyone is typing, is the one for how do you hide keys for databases. I don't know if you had answered that by any chance.
Thank you, Stella. No, I had not answered that question. So, Christopher, that is an important question because when you are working in a production setting, you do not want to expose your database keys. Right now, we have exposed them, right? And you can see that anyone that has access to this code can be able to just, if I put this code on GitHub, for example, well, I do not have an actual database that will cause harm, but if I put here a connection to an actual database in the cloud somewhere, someone might be able to connect to it and be able to delete my data or see my data. So usually the way we hide this is through something called environment variables. So you'd create a separate file called a .env file. So just do .env, and inside it you're going to create your variable. So let's say SQL DB, and then here you'd put in your string that represents the database. And then the other thing that you'll do, because maybe you're pushing this to GitHub, you usually have a .gitignore file, right? So .git I have mistyped that, but when you have a .gitignore file, you just add that .env file inside there so that whenever you are pushing code to GitHub, it does not push the .env file. And then how you access the .env files is through a Python. There's a Python module called python.env. So you can install it using something like pip install python.env. And using this module, you can be able to import all your environment variables. It's going to be reading directly from the .env file and getting access to it. So you're not going to be publishing any secrets. You're going to be doing something like os.environ and then equal db. And so that this module is going to be actually going to the environments file and checking the actual string. So when you publish this to GitHub, no one has access to your actual connection string. And when you are talking about deployment, let's say on AWS, there are services out there that provide this same feature. One such one is called AWS Secrets Manager. So you just go to Secrets Manager, put the secrets there that is equivalent to a .env file, and then import it using the Python .env module, just as you would for a typical application. So that is generally how you handle secrets in a production setting, so that you not expose anything that is uh, user critical in this particular instance. So I hope I have answered your question, not unless you have more granular question that you'd want to ask atop that.
Okay. Also, I'd like to say that Lenny's LinkedIn profile is attached to the description of this video, so you can go and follow him, connect with him, and also if you need any more guidance on FastAPI and backend, I believe he will be responsive to your questions, and even maybe robotics. So I think we have come to the end of this particular session. Great session, Lenny. It was. I really appreciate you taking time. Training is never easy. No, but there's usually a fatigue associated with it. However, it's something that is usually somehow it's just satisfying, but it is usually a little bit tiresome to be that focused. So good job, and also good job also in your career for the focus and the drive to be able to not only implement but also implement to the point where you can be able to comfortably share. So thank you, everyone. Have a nice afternoon. We'll meet in the afternoon. We have a session on, let me just get the exact session title, or JWT authentication and authorization in Django. I think one of the things that you were told is it's important to implement authorization and authentication. So how can we implement those JWT tokens in Django? So that's what we'll be covering in the afternoon. So see you in the afternoon. We have shared the links on your email and even in the various WhatsApp groups. So take care. Bye bye.
Bye bye.